So today's notes, we're going to cover optimization. And optimization is very similar to related rates. It is a little bit different than related rates, but it's kind of similar in structure. They're word problems. However, the main difference for me is that optimization, I think it's one of the most fun and cool, interesting parts of AP calculus, but it also just hasn't really been tested on the AP test in about the last 5 to 10 years. So because of that, it can be tested. I'm going to cover it, but I'm going to kind of cover it as extra credit. So if this lesson ends up getting really, really hard for you and you want to just skip it and forget about it, then just go ahead and skip it and forget about it. This is the last topic in Unit 5. So if you're already overwhelmed, then again, just skip it. If you get to the homework and it's crazy, just skip it. Whatever you want to do there. So we'll kind of go with that. It is extra credit. And so if some of the questions get a little bit too tough, don't sweat it too much. On the test, same thing. We'll have 1 or 2 questions on the test for this topic, and they'll be extra credit. So these are word problems. I do want to talk about what optimizing means. Optimizing means to make something the most efficient or the best, right? If you're going to optimize something, you're making it the best you can make it. And so we're usually going to look out for words like greatest or most, right? Or maybe fewest or least. You can make you can optimize something to have the least amount of something. For example, a water bottle, right? Most standard water bottles all have the same amount of water, 16.9 ounces. So you would want to get the least amount of plastic, right? You would be optimizing it to get the least amount of plastic. Whereas if you're working for a company, you would want to maximize, you would want to get the most profit, and that would also be optimizing your profit. So optimizing can be for the greatest or for the least, right? For a max or for a min. So step 1 on these problems is going to be to determine what quantity you want to optimize. So we're going to determine the quantity to be optimized. And instead of saying optimized, I'll say maximized or minimized. Right? Because essentially that's what we're doing when we're optimizing something. We're either maximizing it or we're minimizing it. Okay, once we've done that, then we want to either sketch a picture or let's define our variables. So sometimes you may not be able to sketch a picture, but you can say kind of like let x be defined as this, let y be defined as that. And so as we kind of go through these steps, just to give you an example, I'll kind of show a problem might be that we want to maximize or find, basically if we said 2 numbers can add up to, say, let's go with an odd number. Let's say 2 numbers add up to 9, and we want to find the greatest product. So the greatest product of 2 numbers that add up to 9. So determine the quantity that has to be maximized. In step 1, it would be the product. We're trying to maximize the product. Okay, in step 2, you can't really draw a picture for that, but I could say let x be the first number and let y be the second number. Right, because that way we're kind of defining the variables. Step 3 would be to write a primary equation. And our primary equation is always going to be for the one that's going to be optimized. So we're going to write a primary equation for, basically the quantity to be optimized. So even though I told you in this example that we have 2 numbers that add up to 9, we're not going to be worrying about the adding up to 9 right now. We're going to be worrying about the product. So what's an equation for a product would be, in this case, x times y. So our product is equal to x times y. Then step 4, this is kind of not always used, but if the primary equation has 2 variables, in this case x and y, So in this case, that did happen. Then we're going to need a secondary equation. And what we're going to do is we're going to use that equation to isolate one of the variables and plug it back in. So the whole goal of this, the reason we're doing that, is we want to only have one variable in our primary equation. So our goal would be to have one variable in that primary equation. So right now it's product is equal to x times y. We only want to have x, or we only want to have y. So what we would do is in step 4, we would say, okay, we know that the sum, x plus y would be the sum, is equal to 9. So we could isolate for y and say that means y is equal to 9 minus x. So then we can use that to plug it back in, x times y. Instead, we're going to plug that into, for y, 9 minus x. And if you can distribute here, it's going to make it easier to distribute. So I'm going to do that now as well. 9x minus x squared. And step 5, we're trying to get the maximum, right? When we've heard the word maximum or minimum, we always take the derivative and set it equal to 0. So step 5, we're going to take the derivative of the primary. We're going to set it equal to 0. We're going to do our number line analysis. And then kind of our last step would be, basically to record the answer, or to report the answer. So that might be plugging it back in to get y. That might be plugging it back in to get the product. So here you might need to kind of plug it in. And so I'll kind of show you what we mean by that. So anyways, in step 5, right, we would take the derivative. So p prime would be, the derivative 9x would be 9 minus 2x, and we'll set that equal to 0. If we had 2x over, we would get 9 equal to 2x, and we would get x equals 4.5 in this case, or 9/2. Then if we plug that back in to, basically y was equal to 9 minus x, we get 9 equals 9 minus 4.5. We'd also get 4.5. So when I say report the answer, what I mean by that is that a problem could ask us what are the two numbers. And if it was what were the two numbers, then our answer would be 4.5 and 4.5. If a problem instead asked what was the product, well, then the product would be 4.5 times 4.5 gives you 20.25. So that's kind of reporting the answer is that last step. Now, instead of doing the examples here, these examples, some of them are just way too complicated. They're not worth our time. I'm going to do some examples from this document, which I did post along with the video. And I think these examples are a lot better. So the first one says a cryptographer expert is deciphering a computer code. To do this, the expert needs to minimize the product. So step 1 is seeing what are we trying to minimize. So I'm going to just write in minimize product. And again, you don't have to write this if you just you do have to understand what you're trying to minimize though. Okay, so minimize the product of a positive rational number and a negative rational number, given that the positive number is exactly 9 greater than the negative number. What final product is the expert looking for? So the answer they're looking for is the product. So I'm going to we don't need a picture, but let x be our positive number. And we'll let y be the negative number. Okay, so our primary equation is going to be the product is x times y. Then our secondary, or kind of supporting equation, would be that we know the positive number is 9 greater than the negative number. So we'd say x is, right, positive number is 9 greater than, so 9 plus y. If you got this backwards, if you accidentally said x plus 9 equals y, later on, you'll just get x as negative, and you can realize, oh, oops, I flipped them. Not a big deal. So that's our supporting equation. So we're going to take that 9 plus y, and we're going to plug it into the product. It's going to give us product is equal to 9 plus y times y. So that'll give us 9y plus y squared. Okay, now that we've done that, we can take the derivative. So 9 plus 2y, and we're set that equal to 0. Okay, subtract 9, we get 2y equals negative 9. And so we get y equals negative 9 halves, or negative 4.5. Okay, and they want the product. They don't want y, but that's okay. We can now say x equals 9 plus y. So x equals 9 plus negative 4.5. 9 minus 4.5 is 4.5. And when you multiply those together, we get negative 20.25. So this is actually very similar to the first question we did. It used a lot of the same numbers, but just was negative now instead. One negative, one positive. So next question. This is probably the most common that we get, the very most common optimization question. The kind of optimization theme is this farmer who's trying to construct a either pig pen or a fence or something like that. It might be adjacent to a wall, or it might be adjacent to a river. But basically what happens is that you only need 3 sides of fence. So when we read this, it then says, what dimension should the farmer use to construct a pen with the largest possible area? So that largest possible area. So if we draw a picture, we have a stone wall on one side. I'm going to just kind of draw this as a stone wall, right? And then we're only going to use these 3 sides of fencing. So we don't need that third side because that's part of the wall. So we're going to just kind of let this side be x and the height be y. You'd call it length and width, or width and height as well. But what's important here to realize is that the perimeter of this fence does not include the wall, right? Because we only need the dimensions of the fence, right? We're only using that fencing. So he has 100 feet of fencing. And so what we want to kind of talk here about is perimeter versus area. And then we can kind of add on to that is surface area versus volume. So in 2D, when we're talking about perimeter versus area, perimeter is going to be the material that we use, like the amount of fence. And area is going to be the total space. So material will always be perimeter. Similarly with surface area and volume, like if I talked earlier about that water bottle example, the amount of plastic would be the surface area. So again, the amount of material, maybe if you were going to paint a water bottle, the amount of paint would be the surface area, what goes outside. And the volume is the inside space, or how much it can hold. Right? If we had a box, if we were going to build a box out of cardboard, the cardboard would be the surface area, and the amount that the box could hold would be the volume. So that's just something that we should already know from math, but just kind of throwing it in there. So when we say this, pig pen using 1,000 feet of fencing, they never specifically said the word perimeter, but we need to realize that that is the perimeter. Okay. Now, we're trying to get the largest area, so we're trying to maximize the area. So that's going to be our primary equation. So our primary equation is going to be the area, which is x times y. We have 2 variables. Whenever you have 2 variables, you need a supporting second equation. Well, that second equation is from the amount of fencing. So that 100 feet of fencing would need to equal x plus y plus x. Right? That's the perimeter, that outside. Or 2x plus y. So I'll solve for y, so I don't have to divide, and I get 100 minus 2x. So we can plug that in, and we can say this is x times 100 minus 2x. And we'll go ahead and distribute, and we get 100x minus 2x squared. And we can take the derivative. I'll do that down here. So the derivative of 100x is 100 minus 4x. We're going to set the derivative equal to 0. That gives us 100 equals to 4x. Divide by 4, we get 25 equals to x. By the way, I never made a number line You could make a number line here. I'm going to stop it at 0 for a prime. And so anything smaller than 25, like 0, 100 minus 0 is positive. Anything bigger than 25, like say 30, 100 minus 4 times 30 is 120 is negative. And so we see that it's maximizing. I don't really ever make the number lines on these. They're not necessary unless I get 2 answers. But if I only get 1 answer, I get 25. That means that's the maximum. The reason for that is the minimum would basically just be not making a fence here, right? The minimum would be like 0. So there really is no way to minimize this. So that's why we only got 1 answer. Okay, now for the y, right? Y equals 100 minus 2 times 25. So y is going to be 100 minus 50 is 50. And this was in feet, and they say what dimensions should the farmer use? So the dimension should be 25 feet by 50 feet. If they instead said what would be the maximum area, we would multiply those two numbers together and report that in feet squared, because that would have been area. Okay, number 3, a supermarket employee wants to construct an open top box from a 14 by 30 piece of cardboard. To do this, the employee plans to cut out squares of equal size from the 4 corners so that the 4 sides can be bent upwards. This was a common question like in the 1980s and 90s. I haven't seen this question asked in forever except for on practice tests. So it's a little bit weird, it's a little bit funky, but don't worry about it too much. And once you see how it's done, it's really not too bad. What size should the squares be in order to create a box with the largest volume? So we're trying to maximize the volume here. So if we draw a picture, this is a little bit weird, but kind of if we started off with a cardboard, sheet, right? It's 14 by 30. It says we're going to cut squares out of the corners. So out of the corners, we're going to kind of just cut out, remove these squares. Okay, and they're squares, so I'm going to call it x by x. Each one of these is x by x. And so kind of what you would end up with is you don't have to draw this ever, but I'm just going to kind of draw this to show it. You would end up with a piece of material that kind of looks like, let's see, yeah. So it looks like that. And so we would fold, right there, if we kind of made little edges right there, we would fold those edges up and it would make an open box. So if you can kind of imagine is that this side here, this width will turn into 14 minus 2x. And the height will turn into 30, or the length will turn into 30 minus 2x, right? Because we're cutting out x. And then the height of the box, right? Because you're folding this up, the height of the box will be x, right? So you kind of visualize it in like 3D. Right, the height of that box became x. The base of the box is 14 minus 2x. And the length of the box is 30 minus 2x. So that's kind of what it turns into. Now, the only picture that anyone ever draws is that one, but I did want to show those other 2 pictures just so we can see this. And so in this one, we're not going to have 2 variables, so we really only need to do our volume equation. So volume is length times width times height. And so the length here would be 14 minus 2x times 30 minus 2x, and our height would be just x. And I'm going to go ahead and use our calculator on this one. Those numbers are a little bit nasty. So on our calculator, there is a button that says expand. So in algebra, we can go to expand. And we can just type in 14 minus 2x times 30 minus 2x times x. And that'll expand it out for us. And then we want to take the derivative of that guy. So 4x cubed, right? Our volume is 4x cubed minus 88x squared plus 420. The derivative we can do by hand, really, that's easy. Okay, and we're going to set that derivative equal to 0, right? So if you want to just double check your work, you could take the derivative on the calculator. Derivative with respect to x of that guy. And then we will use our solve button. Oh, yeah, I guess it's a good thing we did take the derivative by hand. This was 176, not 166. And so we'll take that, set that equal to 0, comma x. And we get x equals 3 or 35 over 3. So this is where it does actually matter, where we do have to do a sign analysis. So whenever, I'm going to put this as 0 because we can't go negative. Whenever you get two numbers, one of them would be the maximum and one of them would be the minimum. So I'm going to put 3 in here. 35 over 3 is like 12.67, right? It's 36 divided by 3 is 12. Sorry, 11.67. So if I plug in a number like 1, right? If I plug in 1 here, 12 minus 176 is negative, but then plus 420, that's going to be a positive number. If I plug in, say, 10, that's easy to plug in. 12 times 10 squared is 1200 minus 1760 plus 420. That looks like the negative 1760 is going to be bigger. That's a negative. If I plug in, say, 20, we're going to get positive. So we're increasing, decreasing, and increasing. So that means 3 was our max volume, and 35 thirds is our minimum volume. Now let's go back and report. It says, what size should the squares be? So what size should the squares be? So the square should be x equals 3. So the squares would be 3. Now was this in inches, I believe, or centimeters? 3 inches. So our square should be 3 inches by 3 inches. That's the size of the squares. Okay, pretty tricky, honestly, but once you see that one. So our next question is one that gives us an equation instead of drawing a picture. So they're saying a company is producing this smartphone, and the hardest part of this is actually just figuring out what the heck the equation would be. So they do tell us kind of that X is our number of smartphones. Right? But we do need to kind of figure this out because it gets a little bit complicated in here with what our actual formula is because they don't really give us everything. So it does say how many smartphones should the company manufacture and sell to maximize their profit. So we need to kind of remember is that the profit would be equal to, basically how much that basically you earned minus how much that it costs you. So we want to kind of be thinking about how much we earn. So we're going to earn basically 160 minus 0.05x. That's the cost of one. Sorry, that's the amount that it sells for, but then times how many you sell. Right? So that was like the price times how many you sell. That would be our earnings. And then our cost, well, it says that it costs us $60 per smartphone plus just a flat fee of $7,000. So our profits would basically be 160 minus 0.05x, that's our price, times x, times how many we sell, minus 60x minus 7,000. Right, so our profits would be 160x minus 0.05x squared minus 60x minus 7,000. Combine like terms. And so our profits would be negative 0.05x squared plus 160x minus 7,000. You'd use your calculator for this, or you can do it by hand. So our derivative would be negative 0.1x. That should have been 100. Right? 160 minus 60 is 100. Plus 100, and we're going to set that equal to 0. That's going to give us 100 equals 0.1x. If we divide both sides by 0.1, you move the decimal 1 to the right, you would get x equals 1,000 smartphones. Right? Or if you had done this on your calculator, you should have gotten something that kind of, we take the derivative, right, with respect to x of, you'd even have typed in like this line up here, 160x minus 0.05x squared minus 60x minus 7,000. And then we would have taken that and done the solve button. we're going to solve that. Equal to 0, comma x, and you get 1,000. So either way, you get 1,000. Another way to kind of think about this, because I know this was a little bit tricky, would be to kind of think like, okay, the price is 160 minus 0.05, and then the cost per smartphone is 60. So for each smartphone, it's 160 minus 0.05x, and then minus 60. That's, for each smartphone. So you could have done all of that times x, and that would have given you this whole section. So I know this one was just weird. Hopefully the first three made a bit of sense, and this one you kind of understood. But I've never really seen anything like that asked on an AP exam, so don't worry too much on that one. Okay, the next one says a rancher wants to construct 2 identical fences, right? So if we kind of had, and they're next to each other. So 2 identical rectangular fences, and the rancher decides to build them adjacent to each other so that they share fencing on one side. So this is a lot more of a figuring out kind of critical thinking that you might be expected to do. So if we call they're identical, so if we call this x and we call this y, then we know that this is also x, this is also x, this guy's y, this guy's x, and this guy's y. And so that kind of helps us out a little bit. And he wants to construct it so that it has the largest possible area. So what would our area be? Well, our area would actually be, the overall rectangle would be 2x and y. So our area would be 2x, that's our width, or our length times our height times y. So that's what we're trying to maximize. We're trying to maximize the area. Now, our supporting equation, since we have 2 variables, is the 300 feet of fencing. That's the perimeter. So 300 would be equal to x plus x, if I start here, plus y each side, plus, x plus x plus y plus y. Or if you kind of simplify that, there were 4 x sides and 3 y sides. I'm going to solve for y just because I know I can divide 300 by 3 very easily. So 3y equals 300 minus 4x. Divide everything by 3. Y equals 100 minus 4/3 x. So we're going to go ahead and we're going to plug that in here. So area equals 2x times 100 minus 4/3 x. When we distribute, we get 200x minus 8/3 x squared. So I'm going to go ahead and take the derivative. I'll use another color, do it down here. So the derivative is 200 minus 16/3 x would be equal to 0. I'll multiply everything by 3 to get rid of my fraction. And then 600 is equal to 16x. So we have to divide both sides by 16. And I'm just going to write this over here. That gives us x equals 300 over 8, which is 150 over 4, or 75 over 2. So that's our 75 over 2. You could do it as a decimal feet. That would be our x dimension. They want to say what dimension. So that was the x. So for y, we know it's 100 minus 4 over 3 times 75 over 2. That cancels. So we get 100 minus 50, or we get 50. So 75 over 2 by 50 feet. All right, so going back to our homework, right, is, so our homework for tonight is going to be from day 45 homework. Number 1, I think you guys could try it. It is a little bit tricky, but number 1, basically, if you want to try it, you can. I'm going to kind of make number 1 optional just if anyone wants to try. I do have the answers posted, so that'll be fine. But we want it closest to the graph. That's going to be using our distance formula back from Algebra 1. So our distance formula is x2 minus x1 squared plus y2 minus y1 squared. And so kind of x2 could be equal to 0, and x1 could be equal to 2. That's our point. And then we have the formula y equals the square root of negative x plus 8. So you can plug that in for y1, and then you'll end up with one variable. So that's kind of your hint there. Number 2, I absolutely want us to do. It's very similar to one of the ones we just did. Number 3, I absolutely want us to do. It's just giving us an area and talking about perimeter. Number 4, we're going to cross out. It's just weird and we don't need to bother with it. Number 5, we're going to cross out. It's weird and we don't need to bother with it. And number 6, I want us to do. It's very similar to the cutting of the box question, so you can just kind of copy that and just adjust it. And then number 7, we're going to get rid of. So we're going to do basically 2, 3, and 6. And if you want to try 1, go ahead and try it. So that'll be extra credit for you guys. And then I will see you in class on Thursday.